Tenemos una persona. Ah, ya está. Ok.
¿Quieres empezar la transmisión un poquito antes de empezar la charla?
Ahí estamos en vivo en YouTube con 100 millones de viewers.
100 millones, sí.
La popularidad de
tenemos
Frank, impresionante.
Muy bien. Le va a gustar mi hijo, eso de YouTube.
Buenísimo, ahí está llegando harta gente.
Sí, ya vamos por los 35.
Mm.
Ya todavía no son las 12. El Claudio y la Torre, hace tanto que no los veo.
Hola Karina, hier ist der Helge.
Ah, Helge.
Frank hat mir den Link geschickt und hat gesagt, ich darf mit daran teilnehmen. Hola.
Ja, das darfst du. Schön, dich zu hören.
Super.
Mhm.
Und dann auch noch mit so einer komischen Sprache. Moin Helge.
Moin, hallo. Überraschung.
Parece que nos vamos a saludar todos aquí. Ja. Yo quisiera ver si se ve bien de compartir mi pantalla. ¿Puedo hacer eso?
Sí,
O Ignacio, tú vas a decir algo primero.
sí, eso te presento a ti. Y igual podrías tú compartir pantalla ahora inmediatamente, porque no voy a compartir nada yo.
Ok. Al menos para saber si se ve.
Claro.
¿Se ve? Sí, o sea, una vez que lo pongo en presentación ya ahí dejo de ver un poco.
Bueno,
Pero,
¿comenzamos?
bueno, no sé, como...
Sí,
como
yo creo mejor comenzar justo a la hora, así que, bueno, le doy la bienvenida a toda la gente que está ahora conectada con nosotros. En verdad hemos estado recibiendo muchas emails de gente de todos lados. Impresionante la buena recepción que ha tenido esta charla. Y bueno, aparte de tener la opción de escuchar la charla de Frank, la idea de esta reunión era también generar un punto de encuentro en la comunidad de investigadores que están trabajando en el periodo cuaternario en Chile, y por eso también los queremos dejar invitados a que una vez que termine la charla, se queden unos minutos más, porque les vamos a hacer una pequeña actualización de cómo va todo lo referente al proceso de formación de la sociedad. La otra razón también que habíamos decidido organizar esta charla es para tender puentes hacia el mundo de la investigación paleoceanográfica. Estamos conscientes de que hay una comunidad muy activa de paleoinvestigadores en paleoceanografía que generalmente no tienen la misma participación que los investigadores que trabajamos con registros terrestres, y por lo tanto la idea de esta charla es tender puentes hacia ellos e invitarlos también a participar de la Sociedad Chilena de Ciencias del Cuaternario. Y para ello nada mejor que presentar a la coordinadora de esta charla, la moderadora, la doctora Karina Lange, que estamos muy contentos de que haya aceptado nuestra invitación a participar hoy día. Karina es profesora titular de la Universidad de Concepción e investigadora adjunta del Centro COPAS Sur Austral. Bueno, ella tiene una extensa carrera, para quienes no la conocen, en investigaciones paleoceanográficas, trabajos con registros sedimentarios marinos, con distintos tipos de proxy biológicos, geoquímicos, etc. Así que estamos muy contentos de tenerte aquí, y Karina va a introducir a nuestro conferencista hoy día. Así que, Karina, te dejo la palabra.
Muchas gracias. Muchas gracias por esta oportunidad de poder presentar a mi gran colega y amigo Frank Lamy, quien es un investigador senior del Alfred Wegener Institute en Bremerhaven. Frank yo lo conozco hace muchos años atrás, cuando todavía era estudiante en Bremen, un flaco pelilargo que paseaba por los pasillos del edificio de geología marina. Él hizo su doctorado, obtuvo su doctorado en el 98, siendo su profesor guía el profesor Gerold Wefer en la Universidad de Bremen. Como muchos saben, Frank tiene un largo background de investigación y está ya, digamos, ya cerca de 100 papers en revistas de corriente principal, en donde todas sus áreas de investigación se dedican a lo que es la variabilidad climática y oceánica a diferentes escalas de tiempo, desde lo que es la alta resolución en el Holoceno a cambios de miles de años en el hemisferio sur y cuál es esa vinculación con lo que son las teleconexiones interhemisféricas, también interacciones de atmósfera-océano a diferentes escalas de tiempo, también largas, a nivel orbital y tectónico en el neógeno, también interacciones entre las altas y las bajas latitudes del Océano Pacífico Sur. A su vez, Frank tiene una larga data de haber estado en expediciones oceanográficas, de las cuales yo tengo el placer de decir que también he compartido algunas con él. Aquí dejo nomás dos fotos de la última expedición grande que Frank lideró junto con nuestra colega Gisela Winkler de Lamont, que ha sido una expedición del IODP embarcado en el JOIDES Resolution, en donde se han sacado sedimentos marinos de la zona del Pacífico Sur. Y la foto de la derecha es de la expedición del Polarstern, también liderado por Frank, en donde fuimos a la zona del Paso Drake. Como ven, ha sido una expedición un poquito movida en los cruces del Drake. También quiero decirles que con Frank en el año 2014 hemos fundado un grupo de estudio en Alemania, en lo que es el Instituto, el Hanse Wissenschaftskolleg en Delmenhorst, en Alemania, en donde hemos juntado investigadores, colegas de Alemania, de Bélgica, de Inglaterra, Estados Unidos y de Chile, en un grupo de estudio dedicado justamente a ver estas interacciones atmósfera-océano en el Océano Pacífico Sur, a diferentes escalas, tanto desde la instrumental hacia las escalas glacial e interglacial. Las otras fotos que ven aquí son porque siempre uno tiene que tratar también de visitar a sus amigos y tener el tiempo para los amigos. La foto de bien a la derecha es justamente una visita al Instituto de Ciencias del Báltico en Warnemünde, en donde nuestro gran amigo Helge Arts, que también está presente hoy, fue como siempre uno trata de juntar trabajo con un poco de tener tiempo para compartir, y compartir una cervecita, compartir un vinito. Y la foto de arriba es la última vez que he podido verlos antes de la pandemia, en septiembre del 2019, en donde ven también a la señora de Frank, Nicoleta. Y una de las grandes pasiones de mi amigo es el ciclismo. Y la foto de abajo es Frank. Tiene una gran pasión por el ciclismo, es un excelente ciclista también y ha hecho un gran número de tours, digamos, por diversos lugares de Europa. Ahora, Frank, hoy tenemos el gran honor de tenerte con nosotros en esta primera, creo que es la primera charla del aspecto marino, digamos, del aspecto oceanográfico de cambios climáticos y paleoceanográficos. Y yo quisiera, o sea, la charla de Frank va a ser unos 30 o 40 minutos y después, durante la charla, y voy a pasar al inglés ahora, during the talk, I will ask everybody to please mute your microphones. And after the talk, we can raise the hand and unmute ourselves when we have a question for Frank. So we can also use the chat, but sometimes it's a little bit annoying to be doing both things at the same time. But anyhow, everybody is welcome to make questions to Frank, especially if possible in English. If not, we can also accept questions in Spanish. Frank knows Spanish and he talks a mixture of Spanish and Italian. So it will be also easy to have questions for him in Spanish. So I'm not going to read your title, Frank, because I suppose you have it on your first slide. And welcome here to this society, which is, as you know, in the way of being formed officially, the Chilean societies, the Society of Quaternary Sciences. So welcome and thank you very, very much for being here. You are a great colleague and a super great friend. Thank you. I'm gonna leave my thing now, and I think you have now the floor for your presentation.
Ya, ok. Muchas gracias, Karina, por esa introducción y por esos lindos recuerdos y todo eso. Y bueno, voy a presentarles algunas cosas, unos aspectos. Tenía un poco problemas de escoger qué va a ser lo más adapto, pero pienso que he elegido algo interesante para todos, especialmente concentrando en Chile, pero también un poco del IDP y esas cosas. Y ahora, para no mezclar demasiado, como dijo Karina, con el italiano, hablamos mejor en inglés y voy a empezar. I will try to start my presentation now. And this picture here in the background of this first slide, you probably all know. The nice trees in southern Patagonia. In the back, I think this is the Otway Fjord. And you see the trees here with the direction of the wind, so you always know where you're looking to. The west is on the left, apparently. And the strong winds is the most characteristic for me of this landscape there in southern Chile, but also in other areas of Chile. So I'm going to talk about quaternary dynamics, also a little bit with IDP of older stuff, but only very shortly, of the southern westerlies, which are the most characteristic feature of the climate along Chile, but also the paleoceanography, because you all know you're living in the country, it's very narrow, and you are always not far away from the coast, so the oceanography is of course a big influence on the climate and all changes, climate change that is occurring in Chile at the moment and in the last decades. Okay, here I said I try to select some parts that might be of interest to the society, Quaternary society. And I think you are mainly working on land, but I understand that you are also working in the ocean now, or there's a part, maybe also a part of this society that will contain some ocean reconstructions. So I'm trying to link both the terrestrial climate and the ocean changes. That is actually what we were doing over the last decades. and then in the end, only shortly, then maybe I've focused on the last 10 years more on the ocean, on the big picture, Pacific Southern Ocean, but I will show a little bit of that Drake Passage through flow, but not too much in this framework here. So we start a little bit with, well, it's not really an introduction, I only show where I'm sitting now. Then a little bit modern climate oceanography, and then the southern westerlies, and always a link to the ocean on different time scales, on orbital time scales, mainly AGM, but also beyond. Holocene, high resolution and not so high resolution records, and then finally the Pacific Southern Ocean. So I'd like to start. Why is that not working now? Sorry. Not possible to, okay. Yeah, that's where I'm sitting now. I'm on the left picture, you see here Bremerhaven on a, let's say, a nice summer day, which is happening also more and more in the last years, I would say. And I'm sitting actually in this building over here. We have different buildings somewhere right on the other side here. So that's close to the center of Bremerhaven. You see we are on the coast. It's actually a kind of estuary, the Weser estuary. So it's the open sea is directly maybe 10, 20 kilometers downstream. There's the main building of RV. In total, we have nearly 1,000 employees here. It's a quite big institute. And here are some of these sentences, what we are doing here. So we are doing polar research, but also ocean research. So it's not necessarily restricted to polar, though mainly, of course. We try to be one of the world leading research and information infrastructures. The main goal is to improve the observation, so the modern part, but also the simulation and also reconstruction of past, present, and future climates and environments. So all of that is from a polar perspective, and especially there's also focus on ecology. The biology, in fact, is the biggest part of at our institute, the biggest group, let's say. The other important thing, Bremerhaven is one. The other thing is that we have this research vessel, the Polarstern, since quite some years already, in 1984, I think. And that's an icebreaker, which the only ship in Germany which can go to these latitudes we are working on, so to the Arctic and Antarctic. You see here the picture. It's useful for the ice, but it's not only the ice, and Carina knows and Helge knows that also in the Drake Passage, for example, there might not be so many icebergs, but you still have these extreme waves of 10, 15 meters subparty that you need this ship also for not breaking ice, but just for breaking these extreme waves there. And you see we are regularly coming with the ship to Punta Arenas. Here's the picture. And that's the base for many of the cruises that are then heading also to Antarctica and to the German Neumeier station that is there. But it was also the base for our cruises in the southern Chilean area and in the Drake Passage. That was in 2016 when we were there and this picture was taken. Yeah, regarding what we are more doing in our group and also others related, like the geoscience, there is a big focus in the Southern Ocean, obviously, around Antarctica. And this is here kind of the different compartments, the different processes we are trying to study in the Southern Ocean, which are very relevant for global climate. Maybe I always say that the Southern Ocean is probably the most relevant part of the ocean for the carbon cycle, for the carbon pump in the Southern Ocean, but also for all these changes related to the westerlies and temperature changes, heat transfer from high to low latitudes, and also the stability of ice sheets and nutrients and this kind of stuff. And we are trying to do this by reconstructing this in the past using sediment cores, but also we have quite some big modeling group here. Paleodynamic modeling is the name of that group. So we try to work, of course, to bring together reconstruction models. And we also always look into this bipolar interactions, that it's not only Southern Hemisphere, but all is connected, as you know. And that's why we are also closely working together with people in the Arctic, reconstructing climate in the Arctic. And all this, the major goal is to improve our process understanding and also to improve finally also models and to work together with them to improve future climate models. Yeah, that is here this kind of introduction. Now I'm coming into our topic. Why are we going to Chile? It's a nice place, you have good food, you have a very nice landscape. That's one aspect, but the other is, of course, that Chile here, the southern tip, also Argentina, I have to say, I know that there's at least one colleague from Argentina listening, so outside Argentina. And you are both intersecting the Antarctic circumpolar current in the northern part, let's say. Here, these yellow lines are the fronts, the subantarctic front, the polar front. You see that the subantarctic front is just south, presently south of the southernmost Chile. And there's still, in this part here, this is still also partly, at least partly, connected to the Antarctic circumpolar current. It can be called the northernmost Antarctic circumpolar current. And you all know this Antarctic circumpolar ACC abbreviation. ACC system is the most important, probably, the global oceanography. That can be seen on this weird picture here. You see Antarctica in the middle. You see the ACC flowing around, and then along the polar front area, polar front zone, there is important deep water upwelling of deep waters. So there is this window of the deep ocean to the atmosphere that is also very important for CO2 changes on let's say, geological timescales. And in the same time, in this area, a little further north, at the subantarctic front, there's a formation of intermediate water masses, Antarctic intermediate water, that connect them back to the tropical areas. And at the same time, there's close to Antarctica in some areas, Ross Sea, Weddell Sea, for example, there's a formation of this lowermost water, which is the Antarctic bottom water that is then flowing in all the different basins here. Indian sector, Atlantic, and the Pacific is somehow covered here by the speakers. So, okay. Yeah, and then the Westerlies, of course. The Westerlies, my famous topic since several years. I think I'm not the only one in the audience here who's very interested in this topic. And this picture here shows just the seasonal changes here, the colors. You see it's a zonal wind speed. If it's positive towards the red colors, you have strong westerlies. And you see that during your summer, there is a strong, very confined maximum all around Antarctica that is touching the southernmost part of South America. So there's in southern Chile, on the western side especially, there is a wind maximum. And if you go to winter, it looks relatively similar here in the Indian and especially in Indian and Atlantic sector, but there is a much different pattern here. In the Pacific, it's all wider, it's widening and it's extending further north, and that's what you probably know from every winter, that the westerlies extend towards central Chile and even southern part of northern Chile, and bring the precipitation in winter, the Mediterranean climate. So that's a great area. You see that this is probably the most unique area. It's also, sorry for that, it's also more important than Argentina for us, because you're here on the lee side, loop side, on the windward side of the westerlies, and it's optimum for reconstructing the winds. And this is also seen here. This is here, I'm showing that always when I discuss the dust, but I don't want to discuss the dust, don't worry. Just showing this here to see where here is Chile, and this white bluish is sea salt and sulfides that somehow are proxy how the winds are flowing. You see that there's all coming across the South Pacific and then approaching South America, and then somehow stopped, goes a bit north, but many then are also then trapped into the Drake Passage. So this is an area where everything, at least in winter, I would say everything is somehow catched, that is coming from the South Pacific into the mountains, into the southern Andes, and you see then it proceeds. So this is for the reconstructing the westerlies. It's a really optimum area. Okay, these videos can be the NASA website. There are also much more. This is quite old already, but it's still quite impressive to see this. So now, yeah, and the westerlies are one thing. The other thing is the current, the ACC. I already mentioned that. This is here a higher resolution picture, how the ACC really looks like. It's a kind of scaled current speed here, what is shown here. Lighter colors are more stronger surface currents. You see that it's not a band really, as one might think of when you see this general overview maps. It's an area where you have a lot of meandering eddy formation, but you see that there is this band here that is clearly visible in the South Pacific and also here in the other sectors. And if you compare that to the winds, I moved this map here a little bit upside down. You see that there is a close similarity to the currents. So the wind is one of the most, maybe the most important factor for this ACC, but it's not the only one. There's also general thermohaline component in this westerlies, in the ACC, which is often a bit forgotten. But of course, the surface wind are one of the major motor for this wind. And you see how that this part here then is also, of course, controlled not only by the winds, but also by the configuration, because it has to go through the drag passage. And that's why the currents are then here after passing here the central part where there are some submarine mountains, the East Pacific rise, so that this is also an influence. There's free flowing here, but then it has to go here to this area. And you see along Chile, it's comparatively small, or let's say relatively reduced currents, but there's also something important ongoing there. Okay, this is the introduction. Then finally, I mentioned already with this process understanding that the westerlies and the ACC are important for Chilean climate, but they are also important for Antarctica. And that is shown in this picture here. You know that we have here the Western Arctic and the Eastern Arctic ice sheet. And both of them, especially the Western Arctic ice sheet, is presently affected by relatively warm water that is coming up from the Antarctic circumpolar current. So this relative warm, it's not like 10 degrees or so. It's a few degrees, but still relatively warm. It's able to get onto the shelf, on the Arctic shelf, and it might get even into even below the ice shelf, and then starts the melting. That's why this amount and the temperature of this deep water that is coming up along the shelf is very important for understanding what's the future of these ice sheets. And this is also dependent on the ACC and the westerlies in the end, apart from the effects on carbon, which I already touched a little bit. So this is the other direction, let's say, to the south. The westerlies are still very important for these processes. Stability of the Antarctic ice sheet. Yeah, sorry for this here. This is a very old figures, but I think the basic message is still there from 2003 and 2006. There is a trend in the instrumental data enhancement and southward shift over the last 30 years. This is now maybe over the last 50 years. I had no time to look up the newer publications. I think this trend is still there. So the westerlies tend to move towards Antarctica presently. And that was already modeled this 15 years ago. And for the future, for 2300, there's a further southward shift of the westerlies. And this is important implication, especially also for the precipitation in central Chile, as you all probably know, that with the further southward movement of the westerlies, you will get a strong extension also of the dry zone, the semi-arid zone in Chile, which is probably a nightmare for your country. Yeah, so now I come to the data itself. Karina mentioned already, I've been on many cruises here. Most of them have really been to the Chilean continental margin. That was since my PhD in '95. The most important area, there were 3 cruises with a research vessel Sonne. Then there were Joyous Resolution already back in 2002. This is here Valparaiso. And then the new one, Punta Arenas in 2019, where I come back later on. Then we had Polarstern Cruise 2016, which I mentioned, Marine de Fresnes. And then most important, we had a number of cruises with a small research vessel, Gran Campo. This is only a selection, there are more cruises. I think these are the 3 where I've been on. And yeah, I come back to this also in a second. Yeah, I think I mentioned already why Chile with the westerlies was so important, the western part, and this is here this correlation maps of René Garot, and you see here, especially here, that due also to the mountains that you have the strong positive correlation of wind speed and precipitation, so you can use precipitation reconstructions as a proxy for wind, at least in theory, as a proxy for wind changes. The problem is that the precipitation reconstruction is not so straightforward as one would like to have it. But it's an area, once you have rainfall, it's very suitable for this kind of reconstruction. Yeah, and then I come back to my favorite old figure here from the PhD thesis, where we started to look at these cores here from the Sonne cruises, and we saw, oh yeah, here, that's the cementation rate. So the most basic proxy we have actually is increasing further to the south. So once you get further south, you come always more terrigenous material coming from the Andes or from the coastal range. This is a very simplistic map, Central Valley. And this has also been known before and already from the 70s with seismic studies that there is this volume change in the whole sediment volume along the continental margin that is strongly increasing and is also correlated somehow to the precipitation. Yeah, that's fine. That was the starting point. And then we started to look and found out based on surface sediment. With the marine geology, you always start to look into the surface. So the modern sediments, you have kind of number of modern sediments and see the pattern is here, north, south, changing. Why can that be? And what we found is that we have here in the northernmost, so this is Norte Chico here, this is 27 degrees Copiapó, off Copiapó more or less. You have kind of different lower iron aluminium ratios than further south, and that's probably related because you presently don't get a lot of material from the Andes, which have simplistic, again, higher iron content because of more basaltic source rocks. That was also then visible. If you go further south, you get always more. And that was kind of the base for interpreting this also in terms of precipitation, because in the northernmost part, these stripped lines here are dry valleys that are presently not active, but they were probably active in the past when it was more humid and could bring material from the Andes down here, where in the south, you know, there's always rivers cutting through the coastal range and bring a mixture of coastal range material and Andean. This just is more kind of historic figure. That was also historical, that we used this iron aluminium ratios to go back to 120,000 years. That was this northernmost core we had at that time. And you see that we found some quite nice cycles here across this time, and they correlated to the precession. That was actually one of, I think, there's another paper also in 1980, was one of my first paleo papers after the surface sediments. And then you see there is a nice correlation with precession. And the question is, why is precession? It's one of the orbital parameters of our Earth. Why is that so important here? At that time, we just observed that this is like this, but it was not so clear why that should be. But we went back to this area in 2010, and this time with this big equipment here from the University from Marum, University of Bremen, the so-called MEBO, Meeresboden Bohrgerät in German. And with that, you can go deeper. And we had one site there that is very close to the OGOB site we had here, a little bit further, nearer to the coast, so closer to the Copiapó River even. And that went down to 57 meters, which you never reach with normal conventional coring. So it's it's not ODP, but it's kind of long piston coring, and another one even more. And this one here was difficult to work on that, but in the end, we managed to look again into this precession, and now we had also more process-oriented story of that back to 1 million years. And that was also thanks to modelers involved there. There was Jean Chia, who was the modeling part and main modeler in this story, and he came up with some idea why this could be, that you have this precession dominance. And this is the record now. So the uppermost part is like the one that I showed before from this shorter core from 1998. And then we extended this here back to about 1 million years. So there's also isotope stratigraphy that's relatively safe, this stratigraphy. And we also did then some fine tuning based on the isotope, but you see that all of these individual precession cycles, it's about 23,000 years, they are visible here. In this record, there's also some kind of long-term modulation. And you see that this is really unusually strong, the precession cycle. It's stronger than in any record, except maybe for monsoon areas. There it's also very strong, but in extratropical records, it's normally not as strong. And there's a very strong coherence between the iron calcium, which is kind of terrigenous input total towards biogenic, and there's a strong precession control. If you look below here, you see this is the Antarctic ice core temperature. And this is, it shows, it has also some precession, but it's not so dominant. It has dominated by, at least after the mid-Pleistocene transition, it's dominated by 100,000 year cycles, glacial interglacial, the big glacial interglacial. So there's no it's not precession, is much less dominant here. So here's obliquity and eccentricity. But if you look at the sea salt potassium flux, also measured in ice cores, the same stratigraphy, that's a very detailed stratigraphy, you see that there are some shorter term, at least here where there's a high resolution, there is some shorter term variations that are really somehow fitting. Also, we did also some cross-spectral analysis, they're fitting to our records. So there is something in this potassium flux, and this is used as a proxy for sea ice, but it's not so easy. It's not just sea ice. There's also something to do with the cyclones, and the cyclones bring this, when the cyclones pass closer to the sea ice area around Antarctica, they can pick up this potassium, and that is then brought to the ice core sites on the continental plateau. So there's a mixture of the extent of sea ice, but also the cyclones. And the cyclones are again something that is related again to the westerlies also. And on the next figure, you can see the big picture interpretation. If you don't, maybe you can look at the paper if you want to have more details. Also, I also have long time with problems to understand this here. But it's based on the model, it becomes relatively clear because the model can do much more than we can do with our one record. Here's our single point here. And you see here, all these results here are the differences between the precession maximum and the minimum in the model. And you see that there's a strong moisture transport here from the tropical part to this central northern and even central Chile during this precession maxima. And that is related to the subtropical jet. So it's not the low jet, it's not the low altitude winds. It's the higher tropospheric winds, the subtropical jet. And this John Chiang, he had before already a paper that where he described from the modern data that there's a split in this jet. That's somewhere happening here close to the eastern part of Australia. From where on there are like 3 jets across the Pacific. There's a subtropical, a mid-latitude, and then there's a subpolar jet also. And that is different in the other basins, and that is also one of the reasons why the whole westerlies are more extended in the seasonal cycle also. You see that they're different in the Pacific from other sectors. In the end, it has to do with sand temperatures based on the model in the El Niño area in the tropical Pacific. So in the end, the SSTs in that area, they are changing on precession and cycles also, and that is again different from other ocean basins. That is here summarized again in this map here. And then once you're in this tropical part, you're getting a link to the intertropical convergence zone, and then you get a link to the monsoons, and then you are fine with the precession. Then it's a direct insulation forcing again. It's a kind of teleconnection from the northern mid-latitudes to the tropics probably involved here. That's the idea. If that is true, who knows, but that's based on our data. Yeah, back to the old iron story. And if you go further south here, 33 degrees, we get higher resolution. There is again this last glacial maximum now, higher, more humidity. That is the old story. Then a kind of early Holocene, relative more drier conditions, and then increasing again to the late Holocene. That was a classical picture in central Chile. That is also shown in many other records, also in a lot of pollen records. As far as I know, it's still up to date that this is more or less consistent among different records, not the details, but the general pattern. And we also have now, we're still, Jerome Kaiser still has to finish here this paper. This is work that has been done by James Collins before. We have now also other proxies, like more modern, sophisticated, or we want to call that proxies for precipitation. That is the deuterium in N-alkanes in the marine record again. And here are different cores. Here is 30 degrees, there's also the ODP. The problem is here that this is also temperature dependent. It's not only precipitation, as we have quite some big temperature changes, and showing that in a moment. The precipitation, there's a mixture, and that is a bit difficult to figure that out, but it looks that the precipitation, it is okay. I mean, it is more humid in the glacier, it's decreasing in the interglacial, and also the Holocene trend is somehow there. So we still have to write that or finish. Jerome started to write, we have to still to publish this. I think it's very important to have a kind of independent proxy also. Yeah, Holocene then, there's also here the old picture from the, in 41 degrees, so where we had in the past the highest resolution. This is only 8,000 years now, and this actually this piece here only, the increasing trend into the late Holocene, more humid conditions. Interestingly, we had a collaboration also with modelers from Marum that looked into the details here of the last couple of 100 years, the Maunder minimum, Dalton minimum, the solar viability. They found a relation here, and also some kind of mechanistic link to that, that there is a link to the higher tropospheric winds again. Sorry. And it's amazing how good that fits, assuming, considering that the dating is not so exact in this record here. We have some datings, of course, but we don't have here every 50 years a dating or something. That's not the case. But it fits if you consider that, it fits very well. That might be an indication that these small changes due to solar viability might play a role in this centennial scale variations. Yeah, that brings me to Patagonia. So that was then later, before the world for me until 2001, I think the world ended at 41 degrees for me. Also Chile ended there. I've never been further south. And then there was a meeting in La Serena where I met, I think also Patricio the first time and others. And there was also Rolf Kilian. You probably all know Rolf Kilian with this very sad story that he 2 years ago, he passed away working in southern Patagonia. But he opened, let's say, the mind towards the south of Patagonia. Here's Rolf, classical view on his ship when he was sailing the fjord. So he had this small ship, the Gran Campo DOS. You see here, there was also once a meeting between Polarstern and Gran Campo. You see the difference in sizes here. That's quite amazing. And that ship was really, it was an adventure, of course, but it was possible to, here's Rolf again, Helge, I think is here, Jerome. It was possible to get relatively long course, like with this relatively reduced technical equipment. We could get sometimes 12, 13 meters of sediment course in water that's to 2,000 meters, so that was a very unique possibility to get these cores out there. And yeah, that was the base then for following work. And with Rolf, we worked then on the paper to bring together all these different records here. So we are here at 53 degrees. Here's Punta Arenas. Here, there's this extreme precipitation up to 10 meters in the southern ice field here. Here's Torres del Paine, eastern side decreasing. And you see here there are different records that he had already, or we also do some of them together. There's a kind of transect from the open ocean, Magellan Strait, then across the Gran Campo Nevada into this Otway Fjord. And we figured out different records here. Of course, all these records have particular characteristics. Everything is different. Every fjord is somehow different, that it makes it so difficult, so complicated. But if you are a bit generous and look at the general pattern over the Holocene here, 11.5, you see a red phase where these proxies go up here, different proxies, organic carbon, also pollen. Jean-François did them, but also just here siliciclastic accumulation, where you see very relatively high values in the early Holocene. And then we compared that to reconstruction from central Chilean lake here, 34 Laguna Aculeo, I think is the name, which has a kind of lower precipitation and increasing to the late Holocene. And we see always this kind of antiphase with less reduced humidity in the late Holocene after transition phase here in yellow. That was our idea, to bring that together in a kind of view that this might be related to something that we observed during the seasonal changes, which I showed earlier. That maybe the early Holocene was something that is, but that is more summer-like, where there's strong westerlies here over the south, a bit reduced, so drier conditions central Chile, and then late Holocene more colder, winter-like conditions with an extended westerlies to the fjords and then higher precipitation here. I know this is also again simplistic, and lots of things have happened since then. And I'm very happy to go back to these topics also, maybe also within the framework of your society, that we can bring this continental and marine records better together. There's still many open questions, and I would be happy to work with you together on these kind of issues. Yeah, time is running. A little bit oceanography. I have also some new results now from Julia Hagemann, PhD student in our group. There are a number of records here. This is offshore, and now we are moving to offshore. You see here the numbers are the lengths of these records. So if you go far offshore in the north, you get even 700,000 years with a normal piston or gravity core. Then further south, the continental margin are always restricted mainly to only up to the last glacier somewhere, or late interglacial. But there are a few. One is a new one. This was a cruise with the Japanese. Karina and Helge were also involved. It's a little bit offshore, but not so far. And this is a quite nice record. It's still relatively high resolution. It gets still some material from here, from the continent, but it is just a good mixture in 150,000 years. And that's a topic of this work here from Julia, and then compared also to the other available. And here in the next figure you see, oh no, this is then, maybe I skip this. This is just the currents. I don't need it. You know how the currents are. These are the currents? No. Okay, sorry. Time is running here, and yeah, these are the records. And you see this. This is the style of records when you go offshore with the low resolution. You get this here. This is stage 5, 150,000 years, and you see this curve here. This is all a little bit better, maybe. This is again low resolution, and then the other extreme is when you go here to close to the continent, like ODP site 1233, which is this one. You have extremely high resolution millennial, but then you get stuck into stage, what is it, 5.1, also 70,000 years. The same here of Patagonia, of the Magellan Strait, where it's also like 60,000. So her record here, Julia's record, is nice in this connection. It has a reasonable resolution. It can be combined also with high-res records from French colleagues, Pepesiani. And you see that there's a nice Emian. The interesting thing is here, this Emian, which is really warmer. There's the termination before the termination 2. I think it's more like 8 or more degrees, so a very strong warming here. But it's not so much more. Let's say a little bit more than the early Holocene. And this is something we are very interested to see, these extreme warm events, if there's something that could be analog also for the future. You see in this resolution it's also warmer, but it's more difficult. This one is more precise. And the other nice thing of this record is that it's here again. This is here the extension of the glacial Patagonian ice sheet, that it's relatively not too close, but it's relatively close and receives this material. And this is here compilation only zoom into the last 45,000 years. So this is brand new data, and she has different proxies, also biomarker proxies, terrestrial biomarkers, mainly SST also, and there you can make a relation directly between SSTs and input on the same site or in the same archive with no problem with dating. The absolute dating might be difficult, but the relative dating is okay. And she finds here some quite interesting features. There are pulses between 40 and 20,000 years, so this must be most likely pulses also of the Patagonian ice sheet. The question now is how these fit to millennial changes. And there has been now some more work on land also on this time frame here, and we are trying to see how that fits together. And it seems to be that the early glacier, like 40, maybe slightly before the last glacier global maximum, there is higher. That is consistent also with land findings on land there. Yeah, this is the same story with that course from the Holocene, but now for SSTs. I don't want to go into detail with CO2. Also, there's this early Holocene warm period, which is really pronounced. It's also in some other sectors, but in the Atlantic, but it's off Chile. There's a relatively pronounced early Holocene maximum, also northern Chile. But then if you go to the tropical, you get a kind of antiphase. You get a warming rather throughout the Holocene, and that increases, of course, SST gradients might be a reason why you have more westerlies. And then there's also a seesaw effect, probably in the Holocene, which is still discussed controversially. You know, the seesaw in the stage 3 between Antarctica and Greenland on the ice core records, it's somehow also existing probably with SST records in the Holocene. And that's something that is still, I think, on the table. And that brings me to a smaller timescale. This is the work of James Collins, who looked into the last 2,000 years only. That was at the edge of the Alkanor method, I have to say. This is really small fluctuation. You see also a bit spiky, suspicious. But still there is a clear centennial pattern, which is here filtered out. Maybe also some less subcentennial, but there is a quite clear pattern, and he compared this filtered records. Then here's my Fenko to other records, ice core. He also compared to terrestrial records. I think it's not on this figure, that's another figure. But what is kind of interesting, if you look into the northern hemisphere in comparison, if you for the upper one here from this core, so this is off, this is 45 degrees, very high resolution, it's 15 meters in only 2,000 years. You see that there is there might be something again like a seesaw, that there's a northern hemisphere cooling and a kind of warming little ice edge, and maybe cooling on at least a part of the medieval pole climate anomaly. Is the name. Yeah, it's not a strict seesaw, but there are some indications, and that's also something that I think has still potential for the future. Look into this timescales on the ocean. I know that you are doing that on land, but to bring that then also together, ocean land on these short timescales, which are very relevant for future stuff. Yeah, well, these are some of the ideas I had. I think how long do I have still, Karina?
It does. I think it does matter, Frank.
IDP. Yeah. Well, I go through that if you want to read more. These are more of some of these findings that might be interesting for some of you. Well, there's this orbital scale with a wetter LGM. That is a general common knowledge. I think that is fine. But the interesting part is the precession, which is really different from classical, or let's say also higher latitude climate pattern, that you have this precession forcing from that new paper. And there's a link to the tropical Pacific. Oh, sorry. Oh, man. It was the mouse. Holocene, we have this multi-millennial precipitation, the long-term trends, also the SST trends that are probably quite consistent. There is a sub-millennial variability, solar variability could be a play a role, but also what I just showed, it's not mentioned here before, that there might be something here like seesaw pattern also on these shorter time scales. And yeah, open questions is orbital changes, how far this precession forcing goes down. There we don't have the records yet, I would say. Then also the condition warmer than present, what I just showed was the Eemian. This is stage 5.5, the last interglacial, which was warmer. There's still very restricted information from Chile, at least from the marine side. I think it's not much better from the continents, I suspect. There we don't know so much what happened during something like a future or relatively near future, probably. Then we still have these reconcile records west and east, and that I know that we are still discussing also with some people here in the audience here about this, that we still have to talk about this. And then also if there are opposite changes between northern and southern Chile, where's the tipping point between both? So where's this separating? Why is that? That's the ideas. And then now shortly to this drag passage. And that was the cruise where Karina and Helge were on. We had even here, even in Spanish here, our logo. And you see we had a lot of stations there. We had 2 sections across the drag passage, a lot of southern Chile also. But one of the purpose was also to do some preliminary work for this IDP. You need some seismic to propose IDP sites. I'm showing that right after that. But it is a different area, as you can imagine. It's not for anything that this is probably one of the worst areas to work on. But we were, after some problems, we were quite lucky. We have a quite nice transect here. Here's Cape Horn, so this is upside down. You see in the middle of the drag passage, we have a number of cores. And I'm only showing one of them, this 85 here. before I come to that, I go to this preliminary work we did before we went to the Drake Passage. We had this core of the Magellan Strait, and we looked into grain sizes and compared it to existing data in the Scotia Sea, which is much 1,000 kilometers downstream. It's always used as Drake Passage, but it's not. And you see that there's a lot of change here between Holocene and Glacial in the northernmost part, in the sub-Antarctic, and during the Glacial. So this is here kind of reconstruction for the Glacial. There's less less through flow, at least here in the northern part, and maybe plus minus zero further south. And these numbers here are the cooling, the glacial cooling compared based on different records here, the Central Pacific old records, forum assemblages and stuff, but still they are relatively low, let's say 2-3 degrees. And then along Chile, there's a very strong cooling, which is consistent, which is strong increase of the Humboldt current system. And all that water, simplistic again, the water is not going here, is probably going into the South Pacific gyre, going into the Humboldt system and bringing this cold conditions towards subtropical and even tropical areas. So that was the idea. And we always said, oh, we need to transact over the Drake Passage. And then we got at least some cores. And this is from a recently, oh, forgot, it's Wu et al. It's hopefully published very soon. That is one central record, and that's the first time now we look into longer timescales. Again, this story was the last interglacial. It's 150,000 years, that record. It's full of current, also influence, of course, difficult, and of course, somehow also difficult. We managed to figure out different grain size proxies, and you see, maybe important is this figure here. You see the Holocene average here, and then glacial with millennial variability, zack, zack. And then you see here's stage 5, and you see that it is indeed, the current is stronger. So all what we talked about, the Holocene, there's something like an extreme Holocene, extremer than present conditions during the last interglacial in the Drake Passage. That would make sense in this whole picture that you have enhanced water masses through the Drake Passage during warm periods and reduced during the cold periods. We are now looking into all these cores further south because then it should be less pronounced if you go further south. Okay, now the last figures bring me to IDP. And all this work then also led to these sites, as I mentioned already. We had to the Chile margin site. This is based on previous work with another Polarstern cruise, the Central Pacific, but we have 3 sites. We managed to drill 3 sites along the margin. One is off the Magellan Strait. It's the same location than this Marine de Fresnes core with 60,000 years, and this one reaches back now to 700,000 years, but you have it in 270 meters. So that's a resolution that is unique going for this time frame. It's like an ice core for southern Chile, I would say, something like this. And then there's another one that is here a bit offshore, again a bit sheltered from the Turgeon's input, so not so high resolution, but still good enough. And this is 360 meters and goes back to 8 million years. So this is something like a standard long record. It's an area which is very calm here, away from the trench, away from the continent, a very consistent sedimentation back to this time. And that is one of the highlights compared also with this year, of course. Our highlight is to have this standard record back over this long time scale. Yeah, this was such a motivation. There was nothing in the South Pacific before, and there have been a number of other cruises shortly before us in the Scotia Sea and close to Antarctica, so we filled this gap. And that you can see what we are looking at. This is a very nice citation. It's lost. It's Berkey et al. 2018, sorry. That compiles here the forecast, what's the name? This trajectories, depending on our behavior, let's say, from into the future warming to the past. And that is here. You see, this is always breaks in the scale, and you see here the last interglacial. What I showed, the Eemian globally is a little bit warmer. You can say, yeah, where is it? Is it somewhere maybe 2050 or 60 or what? And then if you want to go into even warmer, there's other interglacials that have been, this is 7, this is here, it's stage 11 probably, that have also been warmer, but nothing really as what we expect in 2100. If you want to see that, you have to go at least to to the Pliocene warm period, or even go before to the Miocene if you want really something like what's going on maybe in the next century, if you want to see somehow how that could have looked like. But of course, it's becoming always more difficult if you go to these past times, because the proxies are not so direct and so on. But still, yeah, our aim is to look into Pleistocene, Pliocene. We have a little bit Miocene, but not to this warm period. We have only like the uppermost part. And yeah, we want to see what's going on, ACC dynamics, SSCs and everything. And yes, is here again this problem with the water and the winds, the Westerlies. We were always looking into these maps here on the ship. All the time there was one and the next is a very bad one here. They are so big. They're if you put this on South America, it's the whole southern part is covered by these kind of cyclones. And then we made a lot of plans, always different. Because there is restrictions. I think 3 meters is also the end for the ship, and we also had to skip some sides. But in the end, we always had to see the shield. You see the shield and margin side. So there was good weather when we were here. The good weather was here, but then we managed to go there and we're lucky. So we managed to go there, but not so directly as you might think. We started in May, went here across the South Pacific. It was still okay here, quite okay, relative. You see the dates here, relatively close, some waiting time also. But then it started here after that side, it started to get worse and worse. And then the captain said we could not go back the direct way. We have to go north, away, escape from the cyclones. And then you see here our track here. That was 2 weeks, no? 2 weeks lost practically. And here there was even we have to go to Valparaiso. There was a discussion. We cannot go back here. But in the end, there was, you see, the decision was then to go back again, and then we were able to do the last few days here. Maybe it was 11 days we did the 3 sites here, and then was the end. So that was good enough. It's difficult. I think we have been lucky in the end. And these are again the 3 sites I show you. Only again here the one that is a bit offshore, the long one, the close, the ice core of Chile, or how we want to call it, and that one is a bit disturbed, a lot of turbidite, there's a lot, it's more difficult. Yeah. But in theory, they cover also water masses. This is here a transect of different water masses that you can see that you get into maybe even glacial bottom water here, Antarctic bottom water at that site here. And yeah, you see the resolution, that one very high and the others not so high. And then this is here that long record, the 8 million years record, and you see this is just the cementation rate is around 5-6 centimeters, a bit fluctuation. We have already on board, the nice thing in IDP, you get already a lot of dates on board. You get ages from foraminifera, radiolaria, nanofossils, diatoms. You get paleomagnetics, and you know already where the reversals are. And you can try to figure out how this fits together, and based on this, then you start tuning. You go into a proxy, for example, here is the magnetic susceptibility, and tune that to the global isotope curve. And then you get a relatively detailed H model. And this is now this magnetic susceptibility, and it looks really nice. I would say that is very nice, relatively low values upside down, and then starts to increase. 3.3 is known as the global cold period in the upper Pliocene, and then it starts into the Quaternary. You see all these pulses here, all the glaciers. With every glacier, probably we have now also XF that you can recognize all the glaciers through the Quaternary, and probably this is also something that has to be investigated then for oceanography, of course, but also for the Patagonian ice sheet variability. That is probably the only long record in that scale that can be dated in this scale that is existing, that has to be compared to land records and stuff. That's something for I want to do. Yeah, I have only put a few names, of course, a lot of people around here, and I think this is not exclusive, of course, so if I forget somebody. And yeah, thanks for your interest, and I'm looking forward to the questions.
Thank you, Frank. Thank you very much for your presentation. We can now open the floor for questions, and I would ask whoever wants to have a question for Frank to unmute yourself and raise your hand, as which would be better, or if you want to write it in the chat, I can also look at that. So let's open the floor now for for questions.
Can I ask a question?
Yes, Claudio.
Hi, Frank. It's great to see you. Wonderful talk. I really enjoyed, especially the last part. It just seems very exciting what you're doing with a really long course.
What stuff you knew already?
Yeah, it sounds like it's it's fascinating research.
Right.
And but I just had a really quick question for you that sort of relates more to the beginning of your talk. And this is something I've always wondered about. And a lot of the interpretations of the iron aluminum ratio is always based on this relationship with precipitation. And again, that is also based on a modern analog that shows how precipitation is correlated with westerly wind strength. But I wonder about any non-stationary behaviors that you can have with precipitation and the westerly. So and especially as you go further north along the gradient, and you're looking at these aluminum, iron aluminum ratios across latitude. So I wonder, to what extent really, or can you test the idea of the stationary relationship between precipitation and the westerly wind strength, for example, over time? Because that relationship may actually not hold up over time, especially with the dynamic ocean where temperatures are changing, you're getting warmer bodies of water coming in during different times, maybe in the past. So can you actually test that? Or have you thought about testing that?
Yeah, I think that proxy is quite basic. It's not so linearly related to precipitation, all this stuff. But maybe what I will show there also with these biomarker proxies, which are more, they are outside a lot of problems, but they are more directly, let's say, related to the hydrological cycle than the iron aluminum ratio probably. And they might record these things, but it's also, there's a temperature influence in the tropics, for example, this deuterium stuff that works very well when you don't have a lot of temperature changes, but you do have them here. But maybe towards northern Chile more, the temperature it's less important. From the iron, I don't know how to do that. One could try to do really a calibration with some modern data or something, and then I don't know. But it's also not it's not so straightforward, the iron. Maybe more something like a bulk general sediment input, what I showed in the beginning, that the sedimentation rates, that's for me very convincing. More humid, you have more sediments for erosion and everything. But of course, that's also not quantitative. Yeah.
Great, thanks, Frank.
Yeah.
Thank you, Claudio. Any other people who are leaving but saying thank you very much, Frank, for this comprehensive talk? Yeah, we have another question. Sergio, unmute yourself, please.
Okay. Hi, Karina.
Yeah.
Hi, Frank. Nice to meet you.
Sure.
To see you, in fact. Nice talk. I'm really happy to see all the work that you have done in many years. So cool. I just want to say that don't forget the organic biomarkers.
No, that's it.
Yeah, and this we are trying to validate. We are doing a big effort here in our university to trying to validate the things in a model-based biomarkers, and we are getting really nice results. So, and the idea is go beyond only biomarkers, or is incorporate the stable isotopes in specific compounds. So soon, in a couple of years, you will see the nice results showing these calibration curves in temperature and precipitation. That is the goal. So that is something that we can also use in the continental record. So nice. So and my question is related with that. With Jerome or Yesine, are you planning to look, because now you show delta D in alkanes in C31, I think. So are you planning to use another approach to combine water and precipitation, or to do some calibration curve, or are you planning to do something like that with them, or you didn't think?
Jerome here? Jerome, are you here or not?
Jerome or Yesine, I am thinking the people that is doing biomarkers.
Yes. Yes, I'm here. Hello.
Hi, Jerome. Hi.
Hello, Jerome.
Hello.
Nice to see you.
It's a long time.
A long time.
Yeah. Yes, no. I mean, this is something that we actually put it a little bit aside. Now with that, Frank showed these curves, yeah, that we produce, James Collins actually produced over the last 40,000 years. Maybe, I mean, that's something we are working on the manuscript, and maybe also part of it will show some results based on surface sediment, going a bit towards kind of a calibration, or at least showing that there is a link between the deuterium and the precipitation. But nothing really detailed, no detailed approach for now.
Okay.
But there's a group, I know there's the Dirk Sachs's group, eh?
But are they working there still?
I think they were also trying to
Hey,
work
we can talk on another occasion. We can talk more details there.
Yeah.
Yeah. It's more in the north, I think.
Yeah. Okay.
Yeah, maybe you're right.
Yeah. Thank you, Jerome.
You're welcome.
Fabrice Lambert also has a question. Fabrice, unmute yourself, please.
Hi, thank you. Hi, everybody. I had never seen like all these eddies in the ocean. I'm pretty surprised to see that these currents actually are so disturbed. So I imagine this has a pretty important role in mixing of nutrients and productivity in the end. So do we have any idea if the eddy density was the same in glacial times, or if that changed? And if that had any kind of impact on the proxies that we measure?
Well, I think we cannot capture that directly. You can do some speculations on how that could be. I think there might be some work on that, but even on the model, it's not so extremely well described. No? Or this eddy stuff. No, with the fronts, there's also the fronts now. There are no recent papers with the Southern Ocean fronts that they are not aligned like we always put them on.
Yeah, we know, yeah.
It's the same. They are also fluctuating, jumping. Yeah. No, it's probably important, but we are probably not yet at the point to see that, to reconstruct it.
Yeah, so based on my question, do you think that's anything important that we should actually look into, or do you think that's secondary,
For modeling,
not very...
For modeling?
No, generally like the eddy, density in these currents.
I think it's something very important. As far as I understood, the oceanographic literature is one of the very important.
Oh, okay. All right, thanks.
I think it's not some minor stuff also. Yeah.
Thanks.
No.
Thank you. Do we have any more questions for Frank right now? I'm really amazed, Frank, about the 8 million year or that you managed to take in such a difficult place to drill. You have shown some preliminary results on that one. I suppose there will be a lot of work, not only on the circulation changes, but maybe also on the differences in paleoproductivity for such a long record, which would be actually the first one that gets us back in time. Can you maybe tell us a little bit more what are all the studies going on with this IODP groups?
Well, as you know how that works, in the first 1.5 years, a moratorium or the ship was work, and the 43, for example, is Helge, is the main, let's say, researcher there. He has people working on the SST reconstruction, the whole 8 million years, and where you get also biomarker productivity proxies there. But there were not so many, let's say, working. I think the first interest was the Central Pacific, because everybody wanted to have the pelagic ACC record. He had so much plans, but I think that site has not to be forgotten. It's a very good one. There are some parts that is below carbonate mostly. There's not foreign work is not so easy.
Sure, yeah.
but that's not a problem for the certificate. It's good, so it's a very good site.
Okay, thank you. There is another question by Juan Garcia. Juan.
Yeah, thank you. Hi, Frank. Thank you for your talk. Amazing amount of data and very comprehensive indeed. Maybe if you can refer a little bit about the bipolar seesaw mechanisms during the late glacial, for example. My question is more or less how fast the southern westerlies might react to a driver that might be located in the North Atlantic. I'm thinking, for example, in the AMOC circulation, Atlantic meridional overturning circulation.
Right.
How fast the westerlies might feel that change, if they feel that at all, and if the transmission is mostly through the ocean, or maybe rather is the atmospheric circulation change from the north to the south. What's your view about that?
Yeah, for the glacial termination, I think this is Heinrich event 1, the big change that's occurring right after the beginning of the glaciation in the southern hemisphere. It's starting from 18 to 15 or so. I think there it's probably relatively direct. The idea of the seesaw is that it affects directly the atmospheric circulation through the changes in the intertropical conversion zone, and then you get it to the southern hemisphere. And then probably also to the westerly. What I showed also for the precession, also it's for the seesaw, there are similar processes discussed. And then you have a warming in the south, and the westerlies move southward also, no? During the, let's say, last glacial termination during the Heinrich events. The other question is what's going on later on towards the Holocene. There it's not clear. But I showed there's a speculation. If these smaller changes also are important, the smaller time, maybe even on centennial timescales, if this is in the Holocene or so, if this is really something with seesaw, or what is the reason behind that? Maybe it has nothing to do with the input or Atlantic meridian over circulation, maybe.
So do you think the ACR has anything to do, for example, with the AMOC circulation,
yes, I think in Chile it's more direct. There's more the problem in Antarctica that this original seesaw concept. They say that it's when the signal crosses somehow the Southern Ocean, then it gets smoothed and get probably less abrupt. But we had there's a paper which we had in 2007 discussing that the direct increase in SSTs off Chile. This is an indication that this is more abrupt than what you find in Antarctica. That this is probably an indication of the westerlies that are involved in this direct reaction to the North Atlantic changes, to the AMOC.
Thank you.
There's some uncertainties. I know that there's still.
Yeah, sure. Yeah, I guess so.
Frank, we have a question in the chat from Gabriela Tala, who thanks thank you for the presentation, and she says, how are the southern westerlies related to the decreasing precipitation of the last years in Punta Arenas, considering there is an increase in the extreme climate event frequency?
Well, I'm not a specialist on Punta Arenas climate, but I think, as remember, Punta Arenas is not so straightforward in relation to the westerlies. Somehow there's influence of precipitation from the other side, from the Atlantic side, is a kind of mix. At least what Rolf was always saying. Punta Arenas is kind of mixed. There's also some summer rain coming from. That's probably too far away already from the main mountain area. From the Andes, it's already towards the Atlantic. But I don't know how that. There must be studies about it. I'm sorry. Punta Arenas is. I mean, for central Chile, it's clear. No? That it's just when everything moves southward, it's getting drier. That should be with global warming relatively straightforward.
Yeah. Well, I don't see any more raised hands or chat. As we said, this is live on YouTube also. So I think I will turn over I will turn it over to Ignacio or Fabian, and thank you, Frank, very, very much for being with us. and for the really nice and interesting talk of you today. Okay, and hope to see you soon again.
Thank you, Karina.
I turn it over then to Ignacio. Yeah.
Sí, acá estoy. Bueno, sí, por supuesto, agradecerte a ti también, Karina, por acompañarnos hoy día, por moderar la charla, un montón de registros, un montón de curvas, que quedé un poquito mareado, pero de seguro a mucha gente le va a interesar y probablemente hay más personas que quieran contactar a Frank con preguntas extras o algo así. También quizás podemos hacer el contacto ahí.
Sí,
así
seguro.
Que eso. Bueno, yo quería tomar un ratito en representación de toda la gente que está trabajando en la Sociedad Chilena de Ciencia del Cuaternario para hacer un pequeño update, actualización de lo que estamos haciendo desde que nos juntamos el año pasado en septiembre. No sé si se ve mi pantalla, ¿no?
Sí, sí.
Sí, eso, bueno. Básicamente utilizar, claro, esta charla también para aprovechar de contarles un poco qué es lo que hemos estado haciendo. En primer lugar, hemos estado trabajando en un documento que resume los objetivos, la misión y visión de la sociedad. Esta fue una idea original que se planteó en la reunión virtual. Nosotros preparamos un manuscrito, un texto cortito, y se lo enviamos a una serie de académicos de las distintas disciplinas dentro de las ciencias del cuaternario. Recibimos su feedback y los incorporamos a ese documento, y básicamente algunas de las ideas que se sacaron era construir una sociedad para promover estudios que permitan comprender la historia natural y cultural durante el periodo cuaternario, constituir una institución, un punto de encuentro, de comunicación, interacción entre los distintos grupos de investigación, que es un poco lo que estamos haciendo ahora, fomentar la divulgación científica y la protección de los sitios de trabajo, promover las relaciones de respeto entre los colegas y promover los valores de inclusión, equidad y diversidad, y por supuesto apoyar el desarrollo de personal técnico, estudiantes e investigadores jóvenes. Lo que queremos destacar es que esto obviamente es un documento que va a ser abierto. Vamos a enviar un mail con un link hacia el documento y estamos también súper dispuestos a recibir todas las sugerencias y los comentarios de toda la comunidad para terminar de construir este documento que va a ir, digamos, de la mano con toda la otra construcción y que nos va a definir un poco a nosotros como grupo de trabajo. Ahora bien, el mayor desafío que tenemos por delante ahora es producir un documento de estatutos a través de una escritura pública. Para esto tenemos todos los insumos todo que obtuvimos a partir de la encuesta del Cuaternario Chile que hicimos durante el mes de diciembre del año pasado, y nos dio un montón de decisiones de qué es lo que quiere la mayoría con respecto a temas como las directivas, los socios, las elecciones en las asambleas, y la idea es tomar todos esos insumos y escribirlos y redactarlos a través de unos estatutos. Durante esa reunión virtual de septiembre del año pasado también se decidió que esto se iba a hacer a través de una asesoría legal, a través de la ayuda de un abogado. Hemos estado reuniéndonos con distintos tipos de abogados y finalmente la propuesta que a nosotros más nos gusta es de la abogada Jimena Castillo. Ella, bueno, es licenciada en Ciencias Jurídicas, es abogada de la Universidad de Chile y tiene experiencias con ONG y con asociaciones comunitarias. Y el presupuesto que ella nos hizo para encargarse de la redacción de los estatutos y de todas las gestiones y trámites que les voy a mostrar ahora a continuación es en torno a las 20 UF o 600.000 pesos chilenos, que es más o menos dentro del rango que están los presupuestos que hemos cotizado con otros abogados, pero en base a la conversación que tuvimos con ella fue la que más nos gustó y creemos que va a ser la que más facilite el trabajo del estatuto. Ahora bien, por supuesto que esto también queremos que sea de la forma más abierta posible, y por eso vamos a dar un plazo de 2 semanas a partir del día de hoy para que todos los que quieran sugerir algún abogado distinto que nos ayude, lo hagan a través del email, y nosotros también vamos a contactarnos con esa persona y ver la opción de que sea ese abogado o abogada la que nos asesore. Y bueno, acá hicimos como una especie de hoja de ruta para tener un poco claro cuál es el camino que tenemos que seguir para constituirnos legalmente como la Sociedad Chilena de Ciencias del Cuaternario. Como les conté, el año pasado, en septiembre, tuvimos nuestra reunión virtual que está acá abajo, y eso fue seguido de una encuesta para un poco conocer cuáles eran las ideas de la mayoría de toda nuestra comunidad, y ahora estamos aquí, hoy día, justo ante el próximo desafío, que es la redacción de los estatutos. Esto va a tardar 1 o 2 meses más o menos, pero a la misma vez que estamos redactando los estatutos, nuestra idea también es hacer un concurso para la elección del acrónimo. Para quienes no sepan, el nombre Sociedad Chilena de Ciencia del Cuaternario fue el que mayoritariamente se votó para tenerle el nombre a nuestra comunidad científica, pero sin embargo el acrónimo que ganó fue el de la Asociación Chilena de Ciencia del Cuaternario. Entonces hubo como un desfase ahí, y creemos que la forma más abierta de solucionar eso es haciendo una elección. Por eso vamos a invitar también a todas las personas que estén interesadas de ponerle acrónimos como Sochicua, SS Cubo, todas las que se nos puedan ocurrir, y después vamos a ejercerlo también a un periodo de votación. Luego que tengamos los estatutos ya preparados, también vamos a dar un periodo para que todos quienes quieran leer y comentar y sugerir cambios a estos estatutos lo hagan a través de nuestro canal, nuestra lista de email. Y después de eso, después de que se cumpla ese periodo, vamos a someter los estatutos también a una votación para que, esperando que la mayoría de las personas los aprueben y seguir adelante. Después de que tenemos los estatutos ya acordados, viene una serie de trámites. Hay que ver que el nombre no esté ocupado en el registro civil por otro tipo de sociedad. Eso es bastante rápido. Y después hay varios caminos posibles. Se pueden legalizar ante notario como escritura pública los estatutos, o se puede ir directamente a una municipalidad y ocupar los templados, los moldes para la inscripción de corporaciones que tenga cada una de las municipalidades. Hay ventajas y desventajas en ambas formas, digamos, y es algo también que hay que decidirlo junto con el abogado o la abogada que elijamos para que nos asesore. También con respecto a la municipalidad tenemos una propuesta que es hacerlo en la Municipalidad de Las Condes, básicamente porque tenemos un contacto con la persona que está encargada del registro de las corporaciones en la municipalidad. También pensamos inicialmente en hacerlo en regiones. La idea también es hacer una sociedad que participe y que fomente la participación de regiones, pero debido al contexto de pandemia, creemos que lo más pragmático y lo más simple es hacerlo en Santiago, debido a que es donde está la mayor cantidad de investigadores del Cuaternario, y principalmente porque tenemos este contacto en la Municipalidad de Las Condes, que según lo que nos han contado los abogados, es lo más importante, es tener ese contacto, y va a facilitar todos los trámites. También vamos a estar abiertos a cualquier persona que quiera sugerir hacerlo a través de otra municipalidad, que lo haga también, y no hay problema. Vamos a necesitar tener una directiva provisional al momento de firmar los estatutos, y de la aprobación municipal se requiere firmarlo por una directiva provisional. Por supuesto que estamos abiertos a cualquier persona que quiera participar de eso, que nos escriba, y luego de eso, una vez que estamos inscritos oficialmente, ya ahí pasamos a ser oficialmente la Sociedad Chilena de Ciencia del Cuaternario. Se va al servicio puesto interno, donde se obtiene un root, se puede empezar a abrir una cuenta corriente, empezar a hacer giros y movimientos de dinero también, etc. Y esta directiva transitoria probablemente va a tener la misión de llamar a una asamblea y hacer una votación. No se decía una directiva total, general, que va a asumir los primeros desafíos. Quizás el más importante de eso va a ser la construcción de un reglamento interno que regula las interacciones entre las personas, entre otras cosas, pero que es un mecanismo también para hacer cambios más fácil que a través de los estatutos, que son más generales y que tienen una serie de restricciones. Muy cortito con respecto al tiempo. Básicamente, en general, los estatutos va a tardar en torno a 1 o 2 meses. El tema del registro civil es bastante corto, aproximadamente 1 semana. Si lo vamos a hacer otra vez de escritura pública, puede tomar 2 a 3 semanas extra. La inscripción municipal va a tomar entre 1 o 2 meses, según lo que nos cuentan. Tiempo estimado total, en torno a los 3 a 6 meses, si es que todos ahora cooperamos y que todos apoyamos con esto. Probablemente para final de año ya podríamos estar completamente constituidos legalmente, que es como la misión que tenemos un poco a mediano plazo. Y para terminar, el tema del financiamiento, esto es súper importante, tanto para los honorarios del abogado como para también todos los trámites en estas distintas instituciones. Se va a requerir un financiamiento. Creemos que la mejor forma para hacerlo es a través de una campaña de crowdfunding. Estamos trabajando, esta plataforma ya está casi habilitada. También a su tiempo les vamos a enviar un link para que puedan acceder a ella, y nos gusta hacerlo a través de esta propuesta de crowdfunding en vez de abrir una cuenta corriente directamente, porque esta plataforma es completamente abierta. Las personas pueden ver quiénes aportaron, cuánto aportaron y cuánto nos falta para cumplir la meta. Nuestra meta es juntar 1 millón de pesos para costear todos los costos asociados y para también tener un pequeño fondo para la sociedad al momento de que comience y se constituya formalmente. También tenemos, esta plataforma permite hacer pequeños premios para las personas que donen. También eso es algo que vamos a anunciar, vamos a fomentar la ayuda. Tenemos una lista de emails con casi 130 personas, entonces estimamos que un aporte de menos de 10.000 pesos por cada uno va a ser suficiente para cumplir la meta y para poder constituirnos, pero también es súper importante de que la gente se motive, porque la idea es generar esta sociedad para fomentar la colaboración y para también dejarle un legado no solamente a los investigadores de ahora, sino que a los investigadores futuros, y por supuesto promover todo lo que sea las investigaciones en el Cuaternario. Y bueno, para terminar, 2 cosas. Esto también es un trabajo colaborativo. Yo estoy acá representando al grupo Chicua, que somos nosotros, una serie de investigadores jóvenes de varias distintas instituciones que nos hemos reunido y que estamos haciendo esto obviamente en nuestro tiempo libre, sin ningún afán de lucrar en ningún sentido. Y bueno, agradecerle también a mis colegas que están aquí, que nos han colaborado y que estamos siguiendo esta tarea adelante. Y también resaltar de nuevo de que este grupo es completamente abierto a cualquier persona que quiera participar de todas las instancias que les mostré a continuación. Nos escribe al mail, nosotros estamos felices de agregarlos al grupo de Facebook. Nos falta gente de paleoceanografía, también esto es una oportunidad para invitar a gente que participe de ese grupo, para que se nos una, para que nos aporte su visión y para hacer de que esta comunidad sea lo más grande, lo más diversa y lo más inclusiva posible. Así que, para terminar, voy a dejarle la palabra, creo que a Natalia, que va a mostrar, porque también tenemos preparado un video promocional, así que por favor, quédense un minutito.
Sí, bueno, la plataforma que estamos pensando usar nos pide tener un video promocional para convencerlos a ustedes de que esta es una buena idea y que nos apoyen. Y yo les voy a mostrar, ahí lo están viendo, ¿verdad? Espera.
Sí, ahí se estaba viendo.
Sí, es que eso, tenía que poner que se compartiera el sonido también. Un poquito, es muy cortito.
El Cuaternario es el periodo geológico que abarca los últimos 2,6 millones de años de la historia del planeta.
Está marcado por la ocurrencia de varias glaciaciones conocidas popularmente como edades del hielo, con impactos ambientales a nivel global.
A su vez, es en el periodo Cuaternario cuando aparece el género Homo, y aparecen las distintas especies humanas que se extienden por los distintos continentes de nuestro planeta. Conocer la historia del planeta durante el pasado es importante para entender muchos de los cambios actuales y poder proyectar de mejor manera el futuro de Chile y del mundo.
Los registros con los que estudiamos el periodo Cuaternario incluyen testigos de hielos y de fondos de lagos, sedimentos marinos, estalactitas y estalagmitas al interior de las cuevas, también anillos de árboles y excavaciones paleontológicas y arqueológicas, y una gran diversidad de otras secuencias que registran las condiciones del planeta en el pasado.
Desde el desierto más árido del mundo en el norte del país hasta los extensos campos de hielo de Antártica y Patagonia, Chile es un país con una enorme riqueza y variedad de registros marinos y terrestres, únicos que relatan cambios ocurridos durante el periodo Cuaternario.
Actualmente existen más de un centenar de estudiantes y científicos en las distintas regiones del país trabajando activamente en investigaciones sobre este periodo geológico.
Creemos que es hora de unirnos como una comunidad que potencie la investigación científica y difusión de este fascinante periodo y contribuya así al desarrollo del país.
Con la formación de esta agrupación buscamos impulsar y apoyar la investigación del Cuaternario en Chile.
También nos interesa fomentar la divulgación sobre este fascinante y poco conocido periodo de la historia natural, y al mismo tiempo fomentar la colaboración entre estudiantes y investigadores jóvenes, proteger los sitios de estudio y colecciones geológicas y arqueológicas como parte del patrimonio de Chile.
Hay un bravo digital. Y bueno, después de este increíble trailer, también dejamos aquí abierto la palabra para todos los que quieran comentar, darnos sugerencias, impresiones con respecto a todo esto que les mostré recién. Así que dejo abierta aquí la palabra para todos los que quieran comentar. parece que estamos todos un poco cansados ya, después de tanto tiempo. Pero bueno, de todas formas, vamos a enviar un mail
¿Hay una
con todo
mano alzada? Javi
no veo acá.
Pedreros.
Sí, hola a todos. Mi nombre es Gabriela Pedreros. Bueno, muchos de ustedes no me deben conocer, yo tampoco a ustedes. Llegué por la convocatoria, trabajo en volcanología, soy geóloga y quería felicitar la iniciativa porque si bien existe la Sociedad Geológica de Chile, también tenemos subgrupos de especialidades. Me parece que estaba, hacía mucha falta que existiera una cuaternario que fuera interdisciplinaria en su naturaleza. Así que quería felicitar la iniciativa y también declarar mis intenciones de participar y que espero que prospere en el tiempo. Eso. Muchas gracias.
No, gracias a ti, Gaby. ¿Alguien más quiere comentar? ¿Dar algunos consejos? ¿Impresiones generales?
Yo solo quería felicitarles por la iniciativa, por el video. Yo creo que van a tener mucho éxito con el crowdfunding, espero. Pero de todas maneras, si hace falta o si necesitan algo más de apoyo, ya sea económico o de otro tipo, digamos, con respecto a los aspectos, digamos, de la presentación del estatuto, por favor, cuenten con nosotros.
Genial. Gracias, Claudio.
Por ahí aclarar que estaba preguntando Malala en el chat que se va a difundir, se les va a mandar por mail cuando esté lista la plataforma para hacer las donaciones, y también el video le faltaban un par de ediciones y ahí también se va a compartir.
Hay una mano levantada de Germán.
Sí. Hola.
Hola, Germán.
Hola, ¿qué tal? Oye, bueno, muchas gracias por la charla de Frank. Estuvo súper buena, por organizarla. Lo que yo quería hacer un comentario, no sé, pero me parece que el video que muestran está súper bueno, que me gustó harto, pero creo que está muy ligado al aspecto climático del Cuaternario, y no hay que olvidar que la sociedad del Cuaternario no tiene que ver solamente con la evolución climática, sino que también con la vulcanología, con la neotectónica, y con un montón de cosas que pasan durante el Cuaternario. Solamente para ponerle un foco ahí, para quizá una lucecita para que no quede esa cosa tan sesgada hacia el clima y sea más abierto hacia todas las cosas que tienen que ver con el Cuaternario. Solamente eso como una observación.
Gracias, Germán. Vamos a tomarlo. La verdad es que en el equipo también es bienvenido tu comentario, que eres geólogo, y el de Gabriela Pedreros también es bienvenido, que participe también, porque de esa forma, mientras más interdisciplinario sea el equipo que está constituyendo la sociedad, va a estar mejor representado eso. Así que gracias, va a ser muy considerado tu opinión.
Ok.
Sí.
Tal vez pueden mandar unas fotos para incluir en el video.
Sergio tiene la mano levantada también.
Yo me uno a las felicitaciones de Claudio, me parece excelente el trabajo que están haciendo, y los que quería recomendarle era que si nos pueden dar alguna, que piensen en los medios, Twitter, Facebook y todo, porque así nosotros podemos ayudar a diseminar acá en la universidad donde yo trabajo, puedo pasarle a la gente que tenemos en la facultad y a la universidad para que lo divulguen. Entonces, si viene listo, uno llega y lo envía, no tengo que andar pensando, sobre todo la parte de crowdfunding. Eso es lo más, yo creo que lo que más importa en realidad. Más que el video que me llegue, sino que lo llegue, si lo colocan en un formato Twitter, vean aquí, por favor, voten, paguen, apoyen esta iniciativa, yo lo llevo, lo envío a los periodistas y listo, eso nomás. Pero felicitaciones, me alegro mucho.
Gracias, Sergio.
Gracias, Sergio, por tu comentario. Mira, la campaña de crowdfunding está prácticamente terminada. Esperamos que la semana que viene esté lista. Y dentro de la propia campaña hay un montón, digamos, de redes sociales asociadas a nosotros. y la propia plataforma provee ese servicio, digamos, un poco de informar y divulgar la cuestión. Así que, bueno, como te decían antes, cuando llegue el mail os enviaremos toda la información y, por supuesto, estamos infinitamente agradecidos si puedes hacer lo que comentas, divulgarlo, porque la idea también es que participen estudiantes. Entonces, sería maravilloso que nos ayudarais con eso y a cuanta más gente llegue, más probabilidades tendremos de arrancar con ímpetu. Así que nada, muchas gracias.
Sí. Ya.
Bueno, creo que ahí estamos, ¿no? Sí, ya estamos todos un poquito cansados. Fue una intensa jornada. Darle las gracias, obviamente, a todos los que se quedaron y los vamos a mantener en contacto. Y bueno, cualquier duda, sugerencia con todos los temas que conversamos, no duden en escribirnos. Tenemos como les dije, una lista de email bastante numerosa que sigue creciendo y eso nos va a permitir mantenernos conectados. Es un buen canal de comunicación para todos. Así que nada, reiterar las gracias, especialmente a Karina por acompañarnos hoy día por su voluntad.
No, gracias
Sé que
a
está súper
ustedes.
ocupada.
Sí.
Y a Frank también, parece que ya no está, pero igual le vamos a mandar ahí un saludo. Quizás vamos a pensar en hacerle un socio ahí, darle un premio y una felicitación por toda la compañía que nos ha hecho. Así que eso.
Sí, bueno, Frank pidió que lo mantengamos al tanto también de cómo van las cosas con la sociedad.
Genial, pues muchas gracias a todos y que tengan un buen fin de semana.
Igualmente, muchísimas gracias.
Gracias a todos. Que estén bien.
Chao a todos.